Hello everyone, welcome to the Click Physics 1 course. In this lesson, we will discuss scalars and vectors. So let's get started. By the end of this lesson, you should be able to define scalar and vector quantities, distinguish between scalars and vectors, identify the characteristics of a vector, and represent and name vectors correctly. These concepts will serve as the foundation for all the vector operations that we will study later in this chapter. So physical quantities. In physics, every measurable quantity is called a physical quantity. Physical quantities are divided into two categories, scalar quantities and vector quantities. The main difference between these are very simple. A scalar quantity has magnitude only, while a vector quantity has both magnitude and direction. Understanding this difference is essential because many physics problems involve vectors. Scalar versus vector. Well, let's begin with scalar quantities. A scalar quantity has only a numerical value and a unit. It does not have a direction. Some common examples may be mass, length, time, volume, density, and temperature. For example, if we say an object's mass is 3 kilograms, the information is complete. We do not need to specify any direction. Now let's look at vector quantities. A vector quantity has both magnitude and direction. Examples may include force, velocity, acceleration, and momentum. For example, saying that a car is moving at 60 kilometers per hour is not enough to describe its velocity. We must also specify the direction, such as east or north. So remember, scalars tell us how much, but vectors tell us how much and which direction. Okay, what is a vector? A vector is used to represent a vector quantity. It is shown as a directed line segment, which means it is a straight line with an arrow. Every vector has 4 important characteristics: a starting point called the tail or the initial point, an ending point called the head or terminal point, a magnitude which is represented by the length of the arrow, and a direction which is shown by the arrowhead. The length of a vector represents its size or magnitude, while the arrow shows the direction in which it acts. Okay, so naming the vectors. Vectors can be named in 2 common ways. The first method is using 2 capital letters, one at the starting point and one at the ending point. For example, the vector from point A to point B is written as vector AB. And the second method is using a single lowercase letter, such as vector A. Sometimes we only need the magnitude or length of a vector. Well, in that case, we write the vector name between vertical bars. For example, the magnitude of vector AB is written as magnitude AB. And the magnitude of vector A is written as A, with parallel lines around those. Okay, so remember that the magnitude is just the length of a vector and does not include its direction. Okay, types of vectors. There are several types of vectors that we will study throughout this chapter. These include parallel vectors, equal vectors, different vectors, opposite vectors, negative vectors, unit vectors, zero vectors, and translated vectors. Each type has its own characteristics and application in physics. In the next lesson, we will discuss each one in detail with examples. And that's it, we're done here. Thank you for watching, see you in the next lesson.